Yes, so again, scholars, welcome to the class. So as I said, this is going to be a continuation of last time's class that we had. And last time's class, it was asking us to calculate for mass of a substance from an equation. So to the remarks I got from the different scholars, it simply showed out that many of you understood the class very well. So for those that I didn't get your remarks, yeah, so it is between you and you. Who knows whether you picked out something or you didn't. So today's class is also being free for everyone, meaning that the class is going to be posted on YouTube. With that on YouTube, today I'm starting with a major key. So once the class is there on YouTube, simply you're going to first subscribe to the channel even before you start. Before you start seeing the class. So you're going to first subscribe to the PCAB Academy. Why is subscribing key here, and why is it being key? It is being key such that it enables our academy to grow further. Then to your part, it enables you be alerted about the free classes that will be uploaded. Without that, you will not get any enhancement or a notification about a class posted. Perhaps there's a free class at times, but you already see for free classes we take even a month minus posting. So what does it take you to? It takes us to a sit down of saying those that have not yet joined the PCAB Academy Premium group, you do join the group, because for that it is a weekly schedule where we have classes mixed with tests. So those that are new, the academy that is past chemistry and biology academy. However, we added also physics is being handled. Some topics of physics that are vital for the UNEB app, they are being added. For those that do not know me yet, the name is here. Yes, so that is the name. You're free to read it because it has been written. So today we are having a class that is coming from a topic, mole concept. So under mole concept, we have looked at how to calculate empirical formula, how to calculate molar mass of a substance, how to calculate mass of a substance from an equation. So today we are bringing in a subtopic of calculating volume of a substance from an equation, or of substances from an equation. Those that haven't yet joined the class, you know that I use these first minutes to explain the academy. So if you're not part, you're going to use this number here. It is written. Now you're going to either inbox to the administrator, or you're going to call the administrator, and you'll be guided on how you can join our classes, because most of you that are here, you're not in the academy, because the link has just been freely shared. Okay, so once you meet the administrator on that number, you'll be guided on how to join. Okay, however, there is some fee that is fixed on it, so don't get scared when you're told the fee. Just feel calm and see how to go about the fee. Then another remark, all the class registration, they have started. So still, for you people that have been not yet registered for that holiday program, you enroll still to this number. You go and you address your issues to the administrator. Still, you'll be compensated, or you will be helped on how to join. So that is also a remark. Holiday class registration has started. Secure your academic strategy or progress at PCAB Academy before it is late, because you might join when the slots are full, so you don't get a vacancy. So with that brief introduction, I think we can start our class. Now, this is going to be about calculation of volume of substances from an equation, as you're seeing there. As you're seeing the subtopic highlights. Now, we are going to first look at the key terms considered. Whenever someone tells you about a volume, there are some key terms that are considered. For example, if someone tells you about mass, there are things that you should consider. Now, how do you know that the item you're dealing with is really telling you that you have to calculate for volume? So anywhere you see such remarks of the key terms, just know you're going to deal with calculation of volume. Number one, you see this short form STP. So STP, it stands for standard temperature and pressure. So where you see standard temperature and pressure, just know that you're going to deal with calculation of volume. The other abbreviation you can see that is RTP, simply meaning room temperature and pressure. Now, going further about the standard temperature and pressure, that will be auto-handled in the A level. But now here in the O level, we just need to know it as a word. But for more, we shall look at gas laws in A level, then we see how we go about the standard temperature and pressure with more notes. Hope that is uptaken. Now, whenever we are going to be having the standard temperature and pressure, we shall be having values, but these values can vary in units. Some of the values can be in cubic centimeters, some of the values can be in liters, others can be in decimeters cubed. So it is according to the question that you have. So given your item is in one of those units, please use the units respectively. If it is not in those units, then you use the one that is given. Okay, so the STP and RTP values can be given in different units: cubic centimeters, liters, or decimeters. Okay, now when values come from the perception of STP, when they come at the perception of STP, they will say, a moment, they will say 1 mole of a gas occupies 22.4 decimeters cubed. This is if it is coming in the perception of STP. The value in decimeters cubed, it will always be 22.4. Okay, if it comes from cubic centimeters, then they will say 1 mole of a gas occupies 400 cubic centimeters if it comes in cubic centimeters. Now, you can really see that there is a difference in the figures of these numbers, but what changes the figures? It is the units. However, they are of the same measurement. It is just the unit changing the figure. So this, likewise, it will come if they ask you for liters. If it comes from RTP, they will tell you 1 mole of a gas occupies 24 decimeters cubed. Now, you should be keen with this, because if we look at STP, for the case of a decimeter cubed, it is 22.4. But if you look at RTP, for the case of decimeter cubed, it is 24 decimeter cubed. So that should be key. That it should be key when you're calculating. The other hand, if it comes from cubic centimeter, then it will be 1 mole of a gas occupies 24,000 cubic centimeters. Okay, so STP and RTP, they are used in gas laws, but they differ by value. Hope you can see that. So let's start on our class question. We see how does it go about. Perhaps you have picked something. So here they are telling us calcium carbonate reacted with hydrochloric acid according to the following equation. Here is our equation. They are saying calcium carbonate into brackets S plus 2HCl hydrochloric acid into brackets AQ. They reacted to give us calcium chloride aqueous AQ plus water H2O, which is a liquid. Then on the other hand, they are telling us plus carbon dioxide, a gas. Now here we had to have the arrow. Here we had to be the arrow pointed like that. Now, How do we know reactants and the products? In our equations, we always have products, we always have reactants. Now, always there are compounds or substances that are at the back of the arrow. Those ones are reactants. What do I mean? Calcium carbonate here and hydrochloric acid here, they are at the back of the arrow. So they are the reactants. Call that ARA. They are the reactants. Then, calcium chloride, water and carbon dioxide, they are the products. Call that P. So always where the arrow is facing, they are the products, and at the back of the arrow, they are the reactants. However, we want to first know how we deal with how do we read an equation. That is a key. We want to know how do we read an equation. So we are starting with this one here. So we are seeing calcium carbonate, that is CaCO3, and it has a S here. Now, whenever we have no number on the left of a compound, are you seeing where I'm putting this red arrow? Whenever I don't have a number on the left of the compound or substance, it is cleaved to have 1 mole. So when we are reading this calcium carbonate, we say 1 mole of calcium carbonate, which is different. If here was a 10 in front of the calcium carbonate, we're going to say 10 moles of calcium carbonate, but we do not have it there. So it is 1 mole of calcium carbonate. But the further we go, we are seeing some letters in brackets. For example, here they are showing us a S. What does this S stand for? Now, these small letters that you see here in the equation, they stand for the state symbol. They are state symbols. They show us the state of our substances or of our compounds. I know even from primary we have looked at state symbols where we have liquids, we have solids, and we have gases. However, for the sake of chemistry, we add 1 more where we have aqueous. Aqueous, it is symbolized or it is abbreviated as AQ. So where you see S, it means that this calcium carbonate was in solid state. Where you see L, anywhere L, just know that that compound was a liquid. Where you see G, just know that it was in gaseous state. So here we have said, we say 1 mole of calcium carbonate. Why is it 1 mole? Because there is no number on its left. But now we have known that it is a solid. So we read it as 1 mole of calcium carbonate solid. This plus symbol that you see here, it represents reacted with. So anywhere you see that plus symbol, on the side of the reactants, it stands for reacted with. On the side of the reactants, so 1 mole of calcium carbonate solid reacted with, we said that number that is on the left, that number that is on the left of the compound or substance is the number of its moles. And we can see that hydrochloric acid, it has a 2 there. So this signifies that it is 2 moles of hydrochloric acid. I repeat it once more from the beginning. 1 mole of calcium carbonate solid. We are taking this S is the one that we are reading as solid. Reacted with, this plus symbol on the side of reactant, it means reacted with 2 moles, because there is a 2 of hydrochloric acid. Now this AQ, it is just an abbreviation symbol of aqueous. Aqueous. By spelling, someone might ask me what is the spelling of aqueous. So aqueous, it is simply AQ. AQ. Let me put it in small. It is AQ U E or US. So aqueous, what does it mean? Aqueous, it means that what we have, it is in solution form. For example, when you get tea, then okay, let's say you get water. You get warm water, then you put there sugar to form tea. Now that tea that you have formed, it is a solution, but it is an aqueous solution. So where you have water and you dissolve in something, it becomes a solution. But here in chemistry, we call it aqueous. Okay? So this makes hydrochloric acid to be an aqueous solution. This arrow, it means to give us or produced or evolve. this arrow here, the red one. So 1 mole of calcium carbonate solid, we say the plus represents reacted with 2 moles of hydrochloric acid aqueous to give us, here is no number on the left of calcium chloride, so to give us 1 mole of calcium chloride aqueous plus 1 mole of water liquid plus 1 mole of carbon dioxide gaseous. So hope you have known how to read the equations. So I will teach you how to write chemical formulas. Those in the premium group, you remind me we schedule a class. In our classes we have always the weekly best. We see how we write chemical formulas and how do we even balance chemical formulas for those that do not know. Back to the question. Calculate the volume of carbon dioxide evolved when 15.9 grams of calcium carbonate was reacted with excess acid. Into brackets, 1 mole of a gas, it occupies 22.4 decimeters cubed. Now, I always give steps such that they help us to answer. So still I'll give you a step here. I'll call it step 1. Step 1. Step 1. What is our first step that we follow? Now, step 1, whenever you're asked to calculate for volume, this is what you should do. Any question, you calculate for the molar mass of the reactant. Calculate for the molar mass. Calculate for the molar mass of the reactant. Calculate for the molar mass of the reactant. Now, we have known where reactants be. Reactants be on the left, then products be on the right, where the arrow is looking. But still we have more questions. I think let me highlight this so that you can see. The one in blue, they are our reactants. These ones here. These ones. Those are the reactants. Then the ones I'm putting in green, they are our products. The ones that are always at the right, the ones that are always on the right, those ones are always the products. Okay, so in blue we are having reactants, in green we are having products. Now the question is, how do I know the reactant that I'm going to calculate for? Because this reactant at which you're going to calculate for its molar mass, it should always be one reactant. But when you look on the side of our reactants, we are having many reactants. We have calcium carbonate and we have hydrochloric acid. So how do you know that I'm going to calculate for this one? Now, the reactant whose mass has been given in the question, it is the one that you calculate for its molar mass. Let's read the question and we see. They are saying calculate the volume of carbon dioxide evolved when 15.9 grams of calcium carbonate. Highlight that. 15.9 grams of calcium carbonate. It means that the mass they have given us in this question, it is for calcium carbonate. And we have said the reactant whose mass is given in the question is the one that you find for molar mass on step 1. So this means that we are going to find for molar mass of calcium carbonate. After calculating for molar mass of calcium carbonate, this one is now going to be useless. We are not going to use it anywhere. We have known our reactant that we are going to deal with. Okay, so let me rub some of these to create space. Yes, so you have known that you are going to deal with calcium carbonate. The ones in blue, they are reactants, and we have seen how we choose the reactant. That reactant whose mass has been given in the question is the one that you calculate for. So here they gave us the mass of calcium carbonate. So this makes us to calculate for the molar mass of calcium carbonate. Now, you people that didn't attend the class of last time, go to YouTube and see the class. I taught how to calculate for molar mass of a substance, and how to calculate for mass of a substance from an equation. So I'm not going to teach that again. So that is equal to 40, we shall say 40 plus 40 plus 12, 40 plus 12, then plus 48 to give us our answer as 100 grams. Those that didn't see the class, high time you go and watch the class. You know how to calculate for that. So that is step 1. It is done. From there we go to step 2. What does step 2 need from us? Now with step 2, it is very easy. Step 2, it tells us, let me first increase this. Step 2, what do you do? On step 2, simply we compare the molar mass calculated for, compare the molar mass calculated for with the value given at STP, with the value given at STP or RTP. But now this can be according to the question. Now the molar mass that you will calculate for on step 1, on step 2 you're going to compare it with the value given at STP. If we are to go back to our question here, let's see the value they gave us. In brackets they told us 1 mole of a gas, it occupies 22.4 decimeters. From the knowledge that I have given you in the first highlight, you can know that 22.4 decimeters cubed, it is at STP. We can go back here and you see that. Here, I said at STP, they will always tell you 1 mole of a gas occupies 22.4 decimeters. As it is there. Okay, so signifying that this value they have given us, it is at STP. So you're just going to compare. You're going to compare the molar mass you have calculated for in step 1 with that value. So our molar mass is 100 grams. So you say 100 grams of calcium carbonate. They evolved. To evolve is to release. They evolved. What did they evolve? 22.4 decimeters cubed. That is from step 2. After you comparing that, you pick up your equation. You pick your equation, you recopy the equation from the question, you write it onto your question paper. However, I'm not going to recopy it. I'm just going to copy and paste it. So this is our equation here. This one. Just going to copy it very fast here. So you in your paper, you can't paste. So you do what? You copy it. So that is our equation as you see it there. Now, in that equation there, we are going to start the chemistry behind. You remember when I told you how to we read this? We said if there is no number on the left of the compound, it is 1 mole. Okay, so you write this as 1 mole of what? Calcium carbonate evolved. What did it evolve? It evolved. Now we should know the reactant. It is evolving which product? Now in the first step, we knew how we know the reactant that we are going to deal with. We understood that very well, that we know the reactant we are going to deal with, the one whose mass is given in the question. Okay, so we knew that our reactant is calcium carbonate, and even we cancelled this one. It was no longer important. Now we want to know, how do we know the product that we are going to deal with? Because products are many. We are having calcium chloride, we are having water, we are also having carbon dioxide. So how do we know? Now this is how we know. That product that is asked for you to calculate for in the question, it is the one that you deal with on step 2. That product asked for you to calculate for in the question. Let's go in the question and we see the product they said we calculate for. So in the question here they said calculate the volume of carbon dioxide. What does that mean? It means that all other products are useless. This one, calcium chloride, is useless, water is useless, but the important bit of the question they want to know is this. So we'll say 1 mole of calcium carbonate, it did what? 1 mole of calcium carbonate, 1 mole of calcium carbonate evolved. When you look at where carbon dioxide is, it also doesn't have any number on its left, so it is also 1 mole. It evolved 1 mole of carbon dioxide. Okay, now after writing that first statement, you compare the moles. You're going to multiply the moles that you have with the molar mass that you calculated for now. In the other first place, we had calculated for the mass of calcium carbonate, and it was 100 grams. So we are going to multiply the moles that we have, the 1 mole, with the molar mass that we had calculated for that. So this implies that at this step we say 1 times the molar mass we calculated before, which is 100 grams. 100 grams of calcium carbonate. 100 grams of calcium carbonate. It evolved. Now the step 2, the way you wrote it, you just bring it here, because on step 2 we said you compare the molar mass calculated for with the value given to you at STP. So you're just going to carry this step 2 here, you bring it here still on your second statement. So you say 1 times 100 grams of calcium carbonate, it evolved 1. Now you multiply the number of moles of your product with the value given at STP. Okay, so it evolved 1 times 22.4 decimeters cubed of what? Of carbon dioxide. From that, what is our third statement that we write? On our third statement, we simply now answer the question. It is like 100 grams of calcium carbonate. For them, they produce 22.4 decimeters of carbon dioxide. But the question has some mass of calcium carbonate. It was asking us 15.9. Hope you can see it. 15.9. So from there we come back here and say, what about 15.9 grams, which is asked in the question? So what about 15.9 grams, 15.9 grams of calcium carbonate. So what about 15.9 grams of calcium carbonate? So 15.9 grams of calcium carbonate will evolve. Now people, you have learned some English. You utilize English from here, however much you are in chemistry, but it is key to utilize the English that you have learned. So don't say evolved again. It is in future. So 15.9 grams of calcium carbonate will evolve. Now at this step we are about to complete. However, we are going to cross multiply. The cross multiplication that we have here is not the same cross multiplication that we have in mathematics. How do we cross multiply here? Let me make an highlight. So this is how you cross multiply. You set 22.4, which is on the right, times 15.9 on the left, divide by 100, still on the left. Okay, 22.4 on the right times this one, which is down, divide by which is up. Divide by which is up. So meaning, if I come here, I will say these ones will evolve. These ones will evolve. 1 times 22 decimeter, it gives us 22.4 decimeters, times the one that is on the left, lower left, that is 15.9. 15.9. Then we divide it by 100. Where is 100? The one that is up. The answers that we shall get, they will simply be in decimeters cubed of carbon dioxide. Now, as a mathematician, you put this thing in brackets the way it should be. So you can also put it in brackets. We put this thing in brackets. So here just put the brackets into brackets, then you divide by, you show that division symbol. Now the answer that we are going to get from here, it will be our volume of carbon dioxide produced from 15.9 grams of carbon dioxide. So you come here and say, from our calculation, you say it is equal to, when you divide that, it gives you 3.5616 decimeters cubed. So that is a 3 of carbon dioxide. Now that is our calculation, very systematically correct. So just now reflect on the steps that we have used. Once more I'm going to go through just with a tick, very fast. Once more I'm going through what we have looked at. We said step 1, you calculate for the molar mass of the reactant, and this was our reactant, calcium carbonate. How did we know it? We said that reactant whose mass has been given in the question is the one that you calculate for. Step 2, you compare that molar mass you have gotten with the value at STP according to the question. For our question, it had given us STP. From that, you rewrite the equation. Then how do you know the product? To know the product, here we need is carbon dioxide because it was the one that they asked us to calculate for. The ones that are not asked for you to calculate for, you neglect them. How do you know the reactant? The one whose mass has been given. Then a key highlight, we have said whenever there is no number on the left, that is 1 mole. If there is a number, you read that mole. Simple mathematics, you get the answer. So that is our answer. That. Now, you people, thanks for attending the class. but still it is a highlight. Those that will go to the YouTube channel, if you know you are not yet a member there, you enroll to subscribe to that class. That is what I started with. Subscribe to the channel such that our academy grows. You're not in a PCAB Academy, you're missing out. We are preparing for holiday classes. So you enroll to come, join. How are you going to join? Simply use this number here, inbox so-called administrator. You'll be informed about the registration fees. Very cheap, it is very low, such that we enroll the UNEB. With that, I remain Mr. This name you see here, I will not read it. From our academy, PCAB Academy.